In learning electronics, it is important to be familiar with the breadboard. The breadboard helps us to be more organized in connecting the electronic circuits compared to only using wires. This means we can easily prototype a circuit without using any solders. The breadboard has two different parts. The first part is for concerning about power or for powering, and these are called power lines. So this row and this row is meant to be connected to the negative terminal and positive terminal. The second part of the breadboard is for the components, or they are called component lines. So as you can see, every column is labeled by a number, and every part of the column is labeled by a letter. And so just like the power lines, where every row is connected, in the component lines, every column is connected. And the space here is for the integrated circuits, which I will show later. This, the other side, is also a set of component lines. So, so let's try to make a prototype circuit. So in order to make a circuit, we first need a battery. So now we have a battery. Let's connect the positive terminal here and the negative terminal here. This means that the entire row is connected to the positive terminal, and the entire upper row is connected to the negative terminal. So for example, if we have an electric component such as an LED, let's make it green. For example, if we have an electric component and we connect it to the breadboard, so if we connect the cathode to the negative terminal and the anode to the positive terminal, the electric component should work. And there you go. Because the entire row again is connected to the negative terminal, and then the entire row, the bottom row, is connected to the positive terminal, and so we are able to deliver power to the electronic component. Now now to show you an example of using the component lines, let's transfer the LED here. So now the cathode is connected to this entire column, and the anode is connected to this entire column. So the cathode should be connected to the negative, and then the anode should be connected to the positive. And with this, since the entire row is connected to the negative terminal, and then we connect this column to this row using wires, this column should now be connected to the negative terminal, and the bottom row is now connected to this column, which is connected to the anode. And so if we start the simulation, the electrical component should light up. This means that we are able to power the electric component using the power lines and the component lines. So to show you some more complex ideas of how to show you some more a bit, so to show you the function of the space at the middle, let's use an integrated circuit. So for example, a 5x5 timer will always fit the middle. That means that means that you can just connect. That means this makes it easier for us to be able to connect to the integrated circuit because we only have to access these 8 columns. And it's important to know that every integrated circuit follow this will fit in this spacing. So now what we have done is that we have dedicated certain columns to every leg of the integrated circuit. So to show you this is what a breadboard looks like. And as discussed before, these are the power lines. And then these are the component lines. And at the back of the breadboard, we can see the connections. So we can see that the power lines, the entire row is connected. And then for the component lines, the entire column is connected. So for example, if you were making some complex circuits involving some integrated circuits, then like I said before, integrated circuits such as an L21, an integrated circuit such as an L293D will fit at the middle. And now we can access every leg of the integrated circuits just by connecting the electric components on these columns right here. And one more thing to know about the breadboards is that we can actually separate the power lines from the component lines. So we can remove it like this. In one of my projects, I only used the power lines because sometimes you will be using multiple sensors, multiple electronic circuits, and you will need to power all of them. And so only by using this, you will be able to power every component in your project. You can think of this as much like an extension wire.